Hi everyone, in this video we're going to be looking at the first application of the precise definition of a limit, which is using a graph to find delta. So you'll notice that right here I've copied the precise definition of a limit, leaving off some of the original things that it said. But what we have here is the definition. If the limit as x approaches a of f of x equals L, then we can also say that there's a number epsilon that's more than 0 and another number delta that's also more than 0 that will fit these two criteria. So in our example, we're going to go through the 5 steps of using a graph to find out what delta is. If they give you the value of a, if they give you f of x, if they give you the limit, if they give you epsilon. So they have to give you all of that stuff, and then we can find delta. So what I'm going to do is I'm actually going to use these parts of the definition. The absolute value of x minus a is less than delta, then f of x minus L is less than epsilon. What I'm going to do with that is I'm going to find out what a is, what f of x is, what limit is, and what epsilon is. Okay, so notice right here, this 3 is right where the a should be. Okay, so A is 3. And then I notice that this 2x squared plus x is right where f of x should be. So that is my f of x. And I notice my epsilon right here where e is the 0.2. Okay, so I'm going to take that and make that my epsilon. And finally, I see the limit is 21, and it should say minus here because it's f of x minus the limit. So my limit here is 21. Okay, so now I need to find the upper and lower boundaries of L by doing L plus or minus E. Okay, so this is going to be 21 plus 0.2, which is 21.2. And L minus E is going to be 21 minus 0.2, which is going to be 20.8. Okay, so those are my two values. Now I need to graph all of this. So in my graph, I'm going to do y1 equals my function 2x to the second plus x. I have y2 is going to equal 21.2. And I have y3 is going to equal 20.8. So let me put that in my graphing calculator. I'm going to pause the video, then I'll come back and you'll see it's all in the graphing calculator. So I've put it all into my y equals menu, and you'll notice that if I go to my graph, I don't see the horizontal lines for 21.2 and 20.8. They're missing, because they're outside of my window range, because the top of my screen only goes up to 10. So I'm going to adjust my window settings so that I can see them. So my y minimum, instead of being -10, I'm going to make it like, let's make it something that's going to include 20.8, so I'll go with 19. Okay, and then my y max needs to include this 21.2, so I can make it 22 or 23. So maybe I'll go with 23 there. Okay, so now I should have everything I need. The x min and x max, notice the value of a we're using is 3. So I can go up there and change my x min to 0. And my x max, I can make that 5. So I'm really zooming in on the part of the graph that I need. I'm focusing in on x values close to 3. And y values that are going to include these two values. So now if I hit the graph button, I should be able to see better what is going on here. Okay, so there is my quadratic, and that is one of my values, and that's the other one. So next, I'm going to calculate the intersections of f of x and the horizontal lines. So I'm going to hit second and trace. And I'm going to select number 5, which is the intersection. Now it's asking me for the first curve, and I see that it's giving me the quadratic, which is what I needed. So I'm going to hit enter. The second curve is giving me the y2 value, which is okay. I can use that one. So I'm going to hit enter. And now finally I need to guess. So I'm going to use the right arrow key to get right about to there. Now you can type that in. You don't need to use the right arrow key. So it's up to you. I like to use the arrow key so I can get as close as possible. Now I'm just going to hit enter. So one of my intersections that I got is x equals 3.015384. Now you don't need to keep the whole value that it gives. I did because I feel like that's more accurate, and sometimes it comes down to like the 5th place after the decimal. So you want to make sure that you're as accurate as possible. Now I'm going to calculate the intersection again, but this time I'm going to use the black line. Okay, so second and trace. And the intersection is the 5th thing it can do. The first curve is going to be my quadratic again, and the next curve is going to be this bottom line. So I'm just going to hit the down arrow to get to the other function, the 20.3, and I'm going to hit enter. Now it needs a guess again. So I'm going to move it over to right about where they cross and hit enter one last time. And I find out that that intersection is approximately 2.9457002. Okay, so that is it for step 4. Now for step 5, I have to do my A value, which is 3, minus this value, and then make it positive. Okay, so let me pause the video. I'll do both of those subtractions and you'll see what they are, and then I'll tell you how to find your answer. So what I did is I did my subtraction, and then I made my final answer positive. Now the last thing I need to do is select the subtracted value that is the smallest value. So this is 0.015 and this is 0.054. So this value right here is the smallest value, and that is my answer. So this highlighted value is the answer. Now again, you could round it differently. So 0.015 would be acceptable. So you don't have to keep the entire value, but I like to keep as many decimal places as possible because then you're going to be more accurate in your final answer. So I hope this helped you with that process, and let me know if you have any questions.